The main point of organometallics is the making of new carbon-carbon bonds. And this is critically important in synthesis, where we are typically building up large, fancy, and therefore useful molecules out of small, relatively easily accessible ones. We're going to divide our organometallics into two general types. The one we'll spend the most amount of time on is our classic organometallic nucleophiles, which include the alkyne anions that we talked about in Organic 1, the Grignard reagents, which is a carbon group with magnesium and a halogen, the organolithiums, which contain carbon anions stabilized with a lithium, and the cuprates, which use copper to stabilize the carbon anion. The electrophiles that these compounds react with are alkyl halides, which typically are going to be primary or methyl, and carbonyls, or carbon-oxygen double bonds. Now we're also going to take a look at a couple of other types of organometallics. The Simmons-Smith reagents, or carbenes, which make cyclopropanes, because these are classic teaching technology and therefore ones that frequently appear on your MCAT and your PCAT and your OAT and your GOAT and your DOTE and all those other pre-professional exams. And we'll also take a look at palladium cross-couplings, which are more commonly used nowadays for sophisticated coupling reactions of a number of different types. And as we think about how we're going to divide this material, we're going to consider the classic carbon nucleophiles as basically all doing essentially the same reactions, and they can either react with alkyl halides or with carbonyls. Now it's worth noting that the cuprates are special. They can do some things that the other types of organometallics can't. And then the other two groups that we'll just take a quick look at to become familiar with the general idea there.